Hi there, my name is Lucas Tavares and I am a RavenDB enthusiast. Welcome back to this video part 3 where I'm going to show you the, the difference of experience of vector search with embedding tests between RavenDB and PostgreSQL. Um, well, just to introduce this subject, imagine a database that understands the meaning of what you're looking for. So if I am discussing as the bulk insert we created of 3,000 beverages, how would I seek for a specific beverage that would match and become a good pair with, a sandwich or a meat, barbecue, or cheese? Or what kind of wine would pair with a lasagna? This might be hard to find as a keyword because I'm not mapping the description and it won't be wine for lasagna on the label. So let's dive in. I'm going to show you how does it work in RavenDB. Well, before that, in the prior video, I just started with a quick search to start the indexes, and it took a bit to load, but the RavenDB database has indexed as vector search, embedding text the description of the product instead of the full text search that was mapping vintage, type, label, producer, beverage type to retrieve us the results. So here now we have a full map of the meaning of description field. So we have that vector calculated to this field, and every word that we type on the vector search will bring us the approach number to match results. So what we can see here is that when we look into a product, this wine, we have a description here that doesn't have specifically the name of this product, this wine, but we can find the description here about what kind of meal this wine pairs, right? So cheese, pasta, meats. Okay. We have this the counter here, so we can find this by region. So, well, let's try this. Once again, running the application. Let's jump to the resources, menus, and let's bring vectors. So if I type here wine, as usual, it will bring us several varieties of wine, of course. So based on that, we were using vector search, but he mapped wine. He matched the word as well. But what if if this wine matches like with pasta? Maybe I can find this searching for pizza or lasagna. So let's try it. So here, let's paste lasagna. All right, we can see here that we still find that with this word that we do not have in any description, and we find that. So if I change this to barbecue, the results will become different, and the database recommended beers instead wines because beer matches is a greater pair with barbecue than wine. And well, this is something that understands the meaning of what we are looking for. If I type here like Gorgonzola, I'll probably match again like other kind of beverages that matches with cheese, as long we don't see here any Gorgonzola word. So that's what brings a good experience to that. So if I keep trying things like Gorgonzola Europe, we can see that it will bring from Italy, from France, not from Chile. No results from Chile. We have Spain here, right? So American burger. We can also find some USA. So here we have America. We still have burgers here, and that's it. So we can really find not by keywords, but by similarity. And so this is a RavenDB experience. All requests took around 82 milliseconds. 82 milliseconds. Well, this is really fast. Let's try this on PostgreSQL and see with the same words I tried here and see what we can get from there. Let's stop our application here and switch. Let me switch to Postgre. Right, here we are, database up. So as you can see, we have the same structure here and we have the same type of description. So let's go and search that. Let's see on vector search, if I search for wine, what will happen here? Okay, we do have wines here. We took 600 milliseconds. So RavenDB was really faster. So, well, I could find several kinds of wine. What happens if I type Europe? Oh, no matches. No matches. Why? American. No matches. Let me try something else. Cheese should find something. Let's try. Okay, cheese. We have the keyword cheese, but if I type Gorgonzola, no results. Barbecue, no results. Well, and I'm pretty sure that I'm searching to the same field. I do have here, let's go to the code and watch the difference between the implementation. Right, so I'm using here a mapping as English vector using the field description. While converting to English the search, so it might match. And it did not bring any other results for us. So yeah, I don't understand that. Let me see. What did I implemented as different here? Right. Beverages, paging, vector search, field with text. Well, by text as well. There are no big difference between the methods. In this case, the database just didn't return any results about this. About it. Why? Well, still don't know why, but as I am comparing the database in the same point, at the same point, I can say that RavenDB gave me results without any other configurations. I could also try to find something here. I don't know if where are the indexes? Let me just look for that. Sequences, no. Procedures. I don't see anything happening here. Views, no. Yeah, it's not clear. Why is it not bringing that? It should. Let's try something else. So Pilsen, like a beer, it's not bringing as well. Lager. Oh, lager, we had some results, but lager is inside the text. So based on that, we can see that we have a more powerful vector search in RavenDB for sure. What if I type it wrong? It's still not matching. Well, that's it. Well then, so after this comparison, I think we can just look into both databases and understand that we might do PostgreSQL to work, but I would have to work on that. I would waste time. I would waste hours on that, making it work. On RavenDB, I just search it. The indexes were automatically created, and I could get the result of that feature. So basically, this is the big difference of using RavenDB and using other databases. The RavenDB is really fast, so you could see that in a matter of fact, PostgreSQL is the most powerful database in the world, as the fame says, but RavenDB is as fast as. So when we are discussing about scale, nodes replications, RavenDB will do that like very easily, very dynamically, and very with a smooth experience through Raven Studio. To do that with Postgre, I guess you will need advanced infrastructure knowledge and a DBA high-level strategy to create this in a way that it will be maintainable. And by that, you can see that the amount of effort between databases will change and can make a decision point when you want to choose a technology to develop your product. So I'm going to show you an AI functionality to create user registration from AI prompt. And why is this amazing using RavenDB? Because we can create some dynamic data storage about the AI flow, and we can retrieve that history of conversations until we get a user registration from a chat. So this is incredible because the user registration might come from a person conversation with an AI, and the AI could collect more data than just a regular form. So this is quite an amazing thing. If we configure the prompt properly to your business, we can bring a lot of value to the user experience and to that data gathering, right? So let's get started here. I'm connecting to the RavenDB, and let's run the application. So let's go to our resource, the guest resource here, and as you can see, we have no guests in the database. And the only way for me to start my registration, I need to talk with the AI to make my registry. So let's do this. Let's open a chat. Oh, sorry, I didn't set up the my AI keys. Okay. Let's start it again. So let's do this. Let's open a chat here. And well, hello, welcome to the beverage menu database. So here the AI is asking me to introduce myself, and he wants to know my name, how I prefer to be contacted, and well, let's start this conversation. Let me just take the chat ID. Okay, hi, my name is Lucas. You can chat me on WhatsApp plus a 541. Or you can email me at lucas@litsoft.int.br. Okay, so he could register myself just with that information. I'm good to go. Let me see what kind of data did I had here in my registration. All right, I have a social network, WhatsApp. I don't have any other relevant information. I have no nationality here in this case, and I have my email and my name that the AI get dynamically. So let's register another person here. Let's open a new chat, right? So let's do another step. So my name is David Gilmore. I am the guitarist of Pink Floyd. All right, so he's still asking for more information, right? So what would happen if I had a crash or I didn't respond anymore, and my chat context would expire because, you know, my server just had another instance of a cluster and I just lost memory access? Well, probably the David Gilmore would have to start again. But on RavenDB, what I did here, I stored dynamically the chat. Let me show you the chat context. So here we can see that both chats I created. This one was my chat because I already had a guest ID context, so I can recover that when I don't know, log in with guest anytime, and then I can recover that context, and here I can understand what happened. So I have here the message from the assistant. I had the whole context of the time that this started, and I have also the message from Gilmore when he introduced it himself. So if I use this same ID here to keep the chat conversation, and I could also load the last message. The AI asked me to The AI asked me to provide email address, nationality, and social networks. Let's keep doing this. So my email is davidgilmer@pinkfloyd.com. My Instagram is at David Gilmer Official. I like to drink wine at night and beer during the day. Okay, let's see what the AI will respond. So I recovered that. I recreated the context to the AI, and here we are. We have a registration on the database. Let's see what kind of information was gathered. Good. Drinks, night, day, wine, beer. Social networks, I have Instagram and David Gilmer Official. I had this email and his registration. And what is the amazing part here? If you go to the model on this entity, I don't have all the fields here. I have a dynamic of other relevant information. So what we had here was a true dynamic information provided by the AI. And the AI itself could use this for us further, or we could just track this or create some reports on that. And we could use counters to know how many requests this guest did and to charge him or to do something, to measure something. And that's fantastic because we could automate any kind of data. So imagine that if we had to predict all columns of a database, to try to predict what would the AI feel. Don't you think that the AI might miss some information here? Might waste something that he got from the conversation because it doesn't have a column to save? Would we save a JSON file into a column? I don't think so. So, well, that's it. This is a very amazing thing that I've just created here as a showroom about what could we create as a chatbot flow into a simple web API using RavenDB. That would be really hard to build in Postgre because I would have to create a very generic table. So, all right. Well, that's it for now.